Assalamualaikum and good day to all. So now we are going to discuss extra question that relate with the topic 5 capacitor. Okay, so let's start. Okay, so here we have 5 capacitor and is connected to the battery of 10 volt. Okay, so the question asks you to find charge at capacitor 1 and capacitor 2. Okay, so here you are going to get the value of charge at C1 is because of, based on our knowledge, when you have a parallel arrangement of capacitor, the voltage for each capacitor will be equal to the voltage of the battery. So we already know the value of C1, which is 10 microfarad, and then we know the voltage of the battery is 10 volts, so we can actually use Q equals to CV. Okay, so 10 power of -6 multiplied with the V, which is 10. Definitely you are going to get here is 100 power of -6 coulomb. Okay, but for C2, for you to find it, the first thing first that you need to do is you need to find the C equivalent, or you can actually say that find the total C. Okay, so I'm going to denote this one as C3, this one C4 and C5 to make it easier for me to put the subscript. Okay, so we are going to start with the first part here. Okay, so you can actually see that it's going to be series. The arrangement is a series, so we are going to C2 3 1 over 10 power of -6 plus 1 over 10 power of -6. So C2 3 you are going to get here is 5 microfarad. Okay, so now this arrangement you are going to combine it as 1. So this C23 will be parallel with the C4. So for you to find the C234, you just add up everything, which is 5 power of -6 plus with the 10 power of -6, you are going to get here is 15 power of -6 farad. Okay, so this combination is going to be 1 there. Is going to be 1 like that. So this is C234 combined with the C5, and you can actually see that the C5 and C234 is basically series. Therefore, we are going to use the formula of 1 over C2345 equals to 1 over 15 power of -6 plus 1 over 10 power of -6. So for the value of C234, which is 5, which is basically a C equivalent, you are going to get here is 6 power of -6. 6 power of -6 coulomb. Okay, so once you're done with that, you need to find the Q first. Okay, the Q equivalent, which is the Q for 2, 3, 4, and 5. So you are going to use the formula like Q equals to CV. Okay, so C going to be 6 power of -6, and you connected to the battery of 10 volt. Okay, so you are going to get here is 60 power of -6 coulomb. Okay, for you to solve this kind of questions, okay, you already combine from C2 to C3 and C23 with the C4 and C234 with the C5. Now you are going to reverse your step where you are going to open it reverse way. Okay, so we know that C5 and C234 is basically series, which means that the charge there will be same for both C234 and C5. Okay, so once we already know the charge C234 is basically 60 power of -6, so you can actually find the voltage there. Sorry, it's going to be coulomb. Okay, so you only use V equals to Q over C. Okay, so Q is 60 power of -6, and this C is C234. Okay, the combination of these 234. So here is going to be 15 power of -6. So you are going to get here is, you're going to get 4 volt. Okay, so okay, once you already know the voltage 4 volt here, so you open the combination of C234, which you are going to get this kind of shape, this one, and arrange with this one. Okay, like that. So this is basically C23 and this one is C4. Okay, so when it comes to the parallel, the V there going to be the same value. So C23 also 4 volt and C4 also 4 volt. Okay, so once you already know the 4 volt here, definitely you are going to know the charge. So the same formula, Q equals to CV, but C here is going to be 2 and 3. So here you are going to get 5 power of negative 6, and the voltage is 4 volt. Therefore, you are going to get 20 power of negative 6 coulomb. Okay, and as we know that, okay, when you open the C to 3, you are going to get here is C2 and C3. And as we know that when it comes to the series, the charge will be the same value for both C2 and C3. Therefore, we already get the answer, which is for C2, the charge will be 20 power of negative 6 coulomb. Okay, so for you to solve this kind of questions, definitely you need to combine everything, but then you need to reverse the combinations, and then definitely you are going to get the answer for charge and also potential difference. Okay, let's move on with the next question. Okay, so this question asks you to find the equivalent capacitance. Okay, and then you need to find the potential difference between point A, you need to find the charge stored at C3 here. Okay, so first thing first, we are going to find the C equivalent. So we are going to start with C1, C2, this one, and C1, C2 for this one. Okay, so you can see that C1 and C2 is series. Okay, so for C1, C2, so you can actually use the formula of 1 over, okay, I'm going to put the combination of here is CA to make it easier. CA, which is 1 over, C1 is 5 power of negative 6 plus 1 over with the C2 is 10 power of negative 6. So for the CA combinations, you are going to get here is capacitance 3.33 power of negative 6 farad. Okay, so CA, and I'm going to put it here as CB because the combination of C1, C2 also series, so CB. So I can put here as CA equals to CB, which is 3.33 power of negative 6 farad. Okay, so the combination here, you are going to get CB, this is CB. Okay, so there are C3 at the middle. So here you are going to have CE. Okay, so you can see that from this arrangement here is going to be parallel, so it means I just add up everything. So I already put it there, CAB3. You are going to get here is 8.66 power of negative 6 farad. Okay, so here we are going to draw, so we are going to get here is CAB3, which basically connected with the C2 here and C2 here. So we find the C2 here, the combination of C2 here is basically parallel. So C2 plus C2, you are going to get 20 microfarad at this part. Okay, because it's parallel. So I'm going to put it here as CC to represent the combination of C2 and C2 here. Okay, so I'm going to find the combination of this. So I'm going to put it as C equivalent. Okay, 1 over 8.66 power of negative 6 plus with the 1 over 20 power of negative 6. So I'm going to get my equivalent capacitance. Okay, so I'm going to get here is 6.04 power of negative 6 farad. Okay, so we are done with that. Okay, next we are going to find the potential difference between point A and we need to find the charge stored at C3. Okay, like I mentioned before, you combine everything, you find the C equivalent, but now for you to find the charge and potential difference, you are going to do it in a reverse way. Okay, so you reverse your steps. So you're going to open it one by one. So first thing first, you are going to open like this, but for you to open it like this, you find the charge first. Okay, so use the formula of Q equals to CV. Okay, so you're going to get here 6.04 power of negative 6. The voltage going to be 60 volt. Okay, so here you are going to get 3.63 power of negative 4 coulomb. Okay, so once you get the charge, then you reverse your step, which means that you are going to open it like this. Okay, Okay, so CC here and CAB3 here are going to have the same charge because in series. Okay, so this one going to be 3.63 power of -4, and this one also have 3.63 power of -4. Okay, so from this you need to find the potential difference. Okay, so use the formula of V equals to Q over C. So this C here is going to be the combination of A, B, and 3. Okay, so Q here is 3.63 power of -4 over with the combination of C here. Okay, this one. Okay, so 8.66 power of -6. So you are going to get here is 41.9 volt. Okay, so it means that with this combination here, okay, CB, C3, and CA have the same voltage because in parallel, which means that C3 also have a voltage of 41.9. Therefore, from there, we can actually find the charge stored on C3. Okay, so I'm going to use here I'm going to find the Q equals to CV. Okay, so this is the C3 value. C3 is C3 is 2.0 microfarad. Okay, and the voltage here is going to be 41.9. So you are going to get your charge Q3 as 8.37 power of -5 coulomb, or you can actually put it as a 83.6 microcoulomb. Okay, that's how you do it. Okay, let's proceed to the next question. Okay, so this question is quite different from the previous two question. Okay, so this one is the concept of capacitor reconnected. Okay, so let's start. Okay, so you have two capacitor that connected in series, okay, across 12 volt of battery, and they are carefully disconnected and reconnected back with the positive plate to the positive plate and negative plate to the negative plate. And the question asks you to find the potential difference and restore after they are reconnected. Okay, so when it comes to this kind of questions, okay, it's better for you to draw for you to visualize what happened to the charge and what happened to the potential difference. Okay, it's much easy for you to draw for it first, then you are going to start with the calculation. So basically what happened is connected in series, which means that the charge for C1 and C2 have the same value. Okay, so first thing first, when it comes to this kind, definitely we need to find the C equivalent. Okay, so we are going to find the C equivalent, which means that 1 over 9 power of -6 plus 1 over 12 power of -6. So for the C equivalent, you are going to get the value is 5.14 -6 farad. Okay, so once you find the equivalent capacitance, then you need to find the charge. Okay, the equivalent charge. So use Q equivalent here. So 5.14 power of -6 multiplied with the potential difference of 12 volt. So here you are going to get 6.17 power of -5 coulomb. Okay, which means that C1 and C2 will have the same value of charge, which is 6.17 -5 coulomb. Okay, after is fully charging, is going to disconnect from the battery and reconnect it in parallel to each other with the same positive plate and negative plate. Okay, so this one going to be C1, this one going to be C2, this is positive, positive, negative, and negative. Okay, for this kind of questions, we need to find the charge after it's reconnected. Therefore, we are going to use the concept of conservation of charge. Therefore, Q2 here will be added up with the Q1 here. Okay, so the conservation of charge going to be Q1 plus Q2. This is basically the initial, which means that the net charge before and after reconnected should have the same value because charge cannot be created and cannot be destroyed. So I'm going to denote the after reconnected as Q1 plus Q2, which is this is the condition where we can actually call it as an equilibrium. Okay, it means that there's no more charge moving and the net charge remain the same before and after. Okay, so Q1 plus Q2, okay, because in parallel, so therefore charge going to be add up. So you need to find 6.17 plus with 6.17 power of -5 Q1 plus Q2. So you are going to get your combination of Q1 Q2, which is the net charge is 1.23 power of negative 4 coulomb. Okay, so as we know that when it comes to the parallel arrangement, definitely the potential difference for each capacitor will have the same value. So you can just use the formula of Q equal to CV, and this Q here going to be this value. Okay, so here I'm going to put it as Q1 plus Q2 equals to C equivalent V. Okay, so here you are going to get 1.23 power of negative 4. So the C equivalent for the parallel arrangement going to be 9 power of negative 6 plus with the 12 power of negative 6 for you to find the potential difference. Okay, so you are going to get here is 5.88 volt. Okay, so means that the C1 and C2 after they are connected, the potential difference will be 5.88 volt. Okay, next is you need to find the energy store after they are connected. So after they are connected in parallel. So I'm going to use U equals to 1 over 2 C equivalent V square. So here your C equivalent going to be 9 power of negative 6 plus with 12 power of negative 6, and the potential difference after reconnected is 5.88 volt. Therefore you are going to get here is 3.63 power of negative 4 joule. Okay, oh, I wrongly insert the answer here. So the answer should be 3.63 power of negative 4 joule, which is this is basically the energy store after they are reconnected. Okay, let's move on to the next question. Okay, this question it looks like same as the previous one, but now you have only one capacitor that is connected to 30 volt, and after the charging, the capacitor is disconnected from the battery and is connected across the terminal of the second capacitor, which is previously been discharged. Okay, so here they already give you some value where the final voltage across a 1.2 microfarad, which is the second capacitor, is 10 volt. So the question asks you to find what is the capacitance of the second capacitor, to find energy dissipated when the connection was made. Okay, so the first thing first, definitely we need to find the charge when the capacitor is fully charged. Okay, so you are going to use Q equals to CV. So here you are going to have 1.2 power of negative 6 multiplied by 30. You are going to get here is 3.6 power of negative 5 coulomb. Okay, so it's going to be disconnected from the battery and connected with the second capacitor that are previously been discharged, which is in neutral. So because after they are reconnected in parallel, so we can actually put it as C equivalent equals to C1 plus C2, which means that for you to find the C2, you need to put it C equivalent minus with the C1. Okay, so C equivalent here, I'm going to use the concept of conservation of charge, where Q1 plus Q2 will be equals, the net charge will be equals with the after they are reconnected. But Q2 here going to be 0 because it has been discharged. So Q1 here is going to be Q1, and Q1 plus Q2 is basically Q1 plus Q2 equals to C equivalent V. Okay, so I'm going to replace the Q1, I'm going to replace the Q1, Q2 here with the C equivalent V into these equations, where I'm going to get Q1 equals to C equivalent V, and then I want to replace the C equivalent here. Therefore, it's going to be the Q1 over V. Okay, please take note this V is the final voltage 10 volt, because this is the equations where is reach equilibrium. Therefore, you need to use final V. Okay, instead of 30 volt, you need to use 10 volt. Okay, so I'm going to put it back this equation into this part. Okay, so I'm going to get my new equation C2 equals to Q1 over V, which is this new V after equilibrium, which is at equilibrium state, so equals minus C1. So the Q1 going to be 3.60 power of negative 5 over with the 10 volt minus with the C1 value, which is 1.2 power of negative 6. So you are going to get here is 2.4 negative 6 farad or 2.4 microfarad. Okay, so done with question A. Now we are going to find question B. Okay, so for you to find the question B, you need to find the energy before reconnected and after reconnected, which means that at equilibrium state. Okay, so we are going to find the energy before, which is the energy initial going to be 1 over 2 CV square. C here is only for 1.2 microfarad because that's the only capacitor that has been charged. Okay, so 1 over 2, 1.2 power of negative 6 multiplied with 30 volt. So you are going to get here is, okay, 5.4 negative 4 joule. Okay, and then you find the final energy, which is after they are connected, which is connected with the discharge one. So the discharge one already have some charge over there, so you're going to use 1 over 2. Find the C, use the C equivalent, which is going to be 1.2 power of negative 6 with the 2.4 power of negative 6. Okay, multiply with the V, which is V going to be 10 volt square. So you are going to get here is 1.80 power of negative 4 joule. So the question asks you to find the energy dissipated, which means that initial minus final. Okay, so for you to find the change of energy, so here you are going to get 5.4 negative 4 minus with 1.80 power of negative 4. Therefore you are going to get here is 3.6 power of negative 4 joule. Okay, so done with that, let's move on to the next question. Okay, so this is going to be our last question. Okay, so you have two capacitor of 4 microfarad and 12 microfarad that are connected in parallel. This combination is going to be connected across the battery and disconnected and reconnected back with the positive plate of each capacitor connected to the negative plate of the other. Okay, the things that you need to understand here is when you disconnect from the battery, charge remain there, charge remain at the plate. But if example you connected capacitor, you reconnected the capacitor with a different sign, what happened is the charge keep moving because they are same at a different level. Okay, so you can actually put it as the positive and negative. So you can see that if have a different level, the charge keep moving no matter what happened here, but charge not going to move once the both level in the same value, which means that at this side going to be positive and positive, and this side going to be negative negative, and this is what it means by equilibrium established. Okay, so the first thing first, we need to find the charge at 4 microfarad and 12 microfarad, and because they are connected in parallel, which means that the charge for 4 and 12 going to be different. So I'm going to use Q1 equals to C1V, which is 4 power of negative 6 multiply with the battery voltage. You are going to get here is 48 power of negative 6 coulomb. And you do the same thing for the 12 microfarad. Okay, so 12 power of negative 6 multiply with the battery. So here you are going to get 144 power of negative 6 coulomb. Okay, so once it's fully charged, it's going to be disconnected and reconnected with a different sign. So it's going to be like this. Sorry, I'm going to draw it for you. Okay, so this is like, this is positive and negative of Q1 and connected with a different sign. So this is going to be negative and positive for the Q2. Okay, so it means that is the charge going to keep moving up until the other side of here going to be positive positive and the other side here going to be negative negative. Okay, so we are going to use the concept of conservation of charge because we know that the charge cannot be created and cannot be destroyed. Therefore the charge before and after the equilibrium established will be the same value. Okay, the net charge. Okay, sorry, the net charge. Okay, so I'm going to I'm going to put Q2 here and Q1 here. Okay, it's much easier, right? Okay, so the Q2 minus Q1, minus is because it's connected with a different sign, which is definitely the net charge after will be equals to the Q1 plus Q2, which means that the upper plate here going to be positive and positive, and the lower plate going to be negative negative, and this is what I mean by equilibrium established. Okay, so Q2 Q1. Okay, so we need to find the net charge, which is 144 power of negative 6 minus with the 48 power of negative 6. Therefore, we are going to get here is 9.6 power of negative 5. Okay. Okay, so you use the concept of Q equal to CV for you to find the potential difference. Okay, because they are connected in parallel. So definitely the potential difference they are going to be the same value. Okay, so I'm going to use Q1 plus Q2 equals to C equivalent V. Okay, so this is going to be 9.6 power of negative 5 equals to C equivalent, which is 4 microfarad plus with the 12 microfarad. Okay, and then you get the value of V. So V here going to be 6.04. Okay, so each capacitor after reconnected, equilibrium established, the potential difference is going to be 6 volt. Okay, and the next one, the question asks you to find the energy stored in the capacitor before they are disconnected from the battery, and find the energy stored after they are reconnected, which means that you need to find the initial and final. Okay, so for the initial one, okay, so we are going to use 1 over 2 CV square. Okay, so we find the C equivalent here. So 1 over 2 equivalent going to be 16 power of negative 6, and the potential difference there going to be 12 volt. Okay, so you are going to get your answer is okay, 1.15 power of negative 3 joule. Okay, this is going to be the energy before they are disconnected from the battery, and we need to find the energy after they are reconnected. Okay, use the same formula, C equivalent V square. So here you are going to get 1 over 2. C equivalent is 16 power of negative 6, the combination of 4 and 12. Okay, and the potential difference you already get 6 volt over there, so you are going to get here is 2.88 negative 4 joule. Okay, so I accidentally forget to put another answer here. So basically you have two answer here, which is 1.5 negative 3 joule, the energy stored before, and this one 2.88 negative 4 joule, which is after they are reconnected. Okay, so hopefully you understand the working steps. Hopefully you understand how to solve this kind of questions. Okay, please try your best to answer it. Okay, and if you have any questions, feel free to ask. Okay, so thank you very much, and assalamualaikum and goodbye.